Welcome to The Explainer. You ever wonder what separates an app that just completely crashes during a huge event from one that works flawlessly? Well, today, we're going to pull back the curtain and dive into the 4 hidden principles that make the entire digital world spin. These are the absolute pillars of any successful software system.
You know, it's not just that they have a great idea. It's about how their systems are actually built to handle that success. But what happens when that success comes knocking? Maybe a little too hard, and all at once.
So, every big idea starts out like this, right? On a single server. You've got your web app, your database, a cache maybe, all living together in one nice, simple box. But then, people start to love your app, and users start flooding in. And that simple setup, it starts to crack under the pressure. The result? You get slow load times, frustrated users, and eventually, the whole thing just crashes. To fix this, we need a real blueprint. So in this explainer, here's what we're going to do. We'll look at the challenge of scale. We'll meet the 4 heroes of system design. Then we'll break down exactly what each one does. And finally, we'll get into the ultimate balancing act. Okay, let's dive in.
So that first big hurdle is just getting beyond that one overloaded server. And the goal isn't just to throw more power at it, it's to start separating the different jobs of the system. What engineers call components, like the database or the user login service. So each part can be managed and grown all on its own.
So we kind of evolve the system, step by step. First, you split the web app from the database, putting them on their own servers. Then, to handle even more traffic, you add a load balancer to spread out the requests across a bunch of web servers. And finally, you replicate your database, creating copies just to handle all the read requests. Now, each of these steps helps, for sure, but it's still a reactive approach. To build a truly robust system that's ready for growth, we need to stop just fixing problems and start designing with a core set of principles. And that brings us to the heroes of our story. These are not just buzzwords you hear thrown around. They are the 4 most critical components for building successful software systems. These are the principles that guide every single decision when you're building for massive scale.
And here they are: scalability, availability, reliability, and performance. Now the thing is, these aren't just separate goals, they're interconnected forces. Sometimes making one better can actually hurt another one. And mastering how they all play together, that's the real art of system design. So, let's get a dossier on each one.
All right, first up is scalability. This is all about making sure your application can handle way more load, more users, more data, more everything without slowing down to a crawl. To put it simply, scalability means you are planning for growth from the very beginning. It's the difference between just surviving a sudden traffic spike and being engineered to handle massive, continuous growth month after month. And engineers really have 2 main ways to do this. Okay, so you can scale up by making your one server way more powerful. That's vertical scaling. Think of it like upgrading your personal computer with a faster processor or way more RAM. Or you can scale out by just adding more servers to share the load. That's horizontal scaling. And pretty much all large-scale systems use horizontal scaling because it's way more flexible and you don't run into the hard physical limits of a single machine. Next up, let's look at the twin principles that keep a system up and running: availability and reliability. Now, they sound super similar, and people use them together all the time, but they actually have very distinct and very important roles. Availability is all about uptime, plain and simple. When you go to use an app, is it there? Is it working? It's often measured in 9s, and believe me, the standard for a great service is incredibly high. A lot of top cloud providers will promise you this level of availability, 4 9s. It's kind of the gold standard. It sounds amazing, right? Almost perfect. But what does 99.99% actually mean in the real world, in terms of minutes and seconds? Yeah, that's less than 1 hour of downtime over an entire year. For a service that's used all over the world, that is an incredibly small window for failure. So how on earth do engineers actually achieve this? Well, the strategy is all about getting rid of any single point of failure. You build a redundancy into every single layer, with backup parts just waiting to take over. You use load balancers, so if one server dies, traffic just gets rerouted automatically. And you have failover mechanisms, so if an entire database fails, a copy can take its place almost instantly. Okay, so if availability is about being up, reliability is about being correct. Here's the best way to think about it. An ATM is available if the screen is on, but it's only reliable if it gives you the right amount of cash every single time. A system that's always on but gives you the wrong answer or fails to save your work might be available, but it is completely unreliable and useless. And that brings us to our final hero, performance. Because let's be honest, a system that can scale, that's always available but is painfully slow, well, in the user's eyes, that's still a total failure.
In simple terms, performance is all about speed and responsiveness. So latency, that's the delay before something starts happening. And throughput, that's how much stuff you can handle at once. And in today's digital world, every single millisecond counts. Just think about that for a second. A delay that is shorter than the blink of an eye had a massive direct impact on revenue. This is exactly why performance isn't just a technical goal, it's a fundamental business necessity.
To get this kind of speed, engineers have a whole toolkit of clever techniques. They use caching to store frequently used data somewhere super fast. They use CDNs, which are like mini servers all over the world, to bring content geographically closer to you. And they use asynchronous processing to handle heavy tasks in the background, so you're not just sitting there waiting.
Okay, so we've met our 4 heroes. But here's the catch. In the real world, you can't always maximize all 4 at once. And this leads to the most important and honestly the most difficult concept in all of system design.
This really is the single most important truth. Everything is a trade-off. There is no perfect solution that makes all 4 principles perfect at the same time. Building great systems is all about understanding the constraints and making the right compromises for your specific goals. For example, you might have to choose between guaranteeing every user sees the absolute latest up to the millisecond data versus making sure the system is always available, even if some of that data is a tiny bit out of date. Or you might have to sacrifice a little bit of performance to keep your costs from exploding. These are the strategic decisions that engineers and product leaders are making every single day. So the next time your favorite app loads instantly, or handles millions of users during a live event without a single glitch, or just works every single time you open it, you'll know it's not magic. It's the Fantastic Four: scalability, availability, reliability, and performance, and the careful, intelligent balance of trade-offs that make it all possible.